Hello viewers, welcome to my channel and thank you for watching the videos. In this video, question 15A of 1993, Operations Research UPSC CSC Maths Optional Paper 2. Use simplex method to solve. This is minimization problem. So this can be done by two ways. One, that we can solve it in this manner by minimization, so we will keep it minimizing problem. Another is that we convert into maximization problem and then solve it, and in the end when we get the value of z, we put a minus sign. So positive value we convert it into negative value. That is the procedure. So we will be doing with minimization only. All the constraints are less than equal to, so we can implement simplex method. Simplex method variables. First we will be adding the slack variables. So this is the constraint. In second S2 and in third S3 constraints are same, and in the objective function, which is minimization type, 0 S1 into plus 0 into S2 plus 0 into S3, and all the 6 variables are greater than equal to 0. Now we will be solving this problem. As we select the values, some difference is there from the maximization. So we have written cost function coefficients, which are z function coefficients which are on right hand side, and we put x1, x2, x3, 0. So we get s1, s2, s3, 0 from the first equation from here, from second equation from here, from third equation, because we have kept x1, x2, x3, 0 in constraints, and z value is coming 0 because x1, x2, x3, 0, s1, s2, s3, 0, so z value is 0. And this is our coefficient matrix, which is having the coefficients of constraints. Right hand side value, these are right hand side values denoted by xv, and we write zj minus cj. We take all the terms from right hand side to left hand side in objective function and put it as 0, and we get these values. So in notes, in operation research notes, where I have explained the method, there the table has been made with the help of Taha, and that notation has been followed. But in many books other notations have been given, so I have tried that also here. So what we do, positive value instead of negative, most negative value in zj minus cj, we will take most positive value, and that is 3. This becomes pivot column, and key column also we say key element. Corresponding to this column, we have to find out the minimum ratio. So we divide xv by x2, the xv elements with corresponding x2 elements we divide, and if in denominator negative, as in this case here, we will neglect it. If 0 is there, we will neglect it. So we got 3 is minimum. It means the row corresponding to this, that is s2, is the leaving variable. So s2 is leaving, and s2 is entering variable, and s2 is leaving variable. And wherever this column and row cuts, this element is pivot element or key element. We divide this row by 4 and get here 1 in pivot element, and with the help of this row we make this, means all the constraint elements in this column 0, as well as in zj minus cj we make it 0. Zj we will change, but not with the help of this, we will add Cj in Zj minus Cj and we will get this value, corresponding value all. So in the next slide I have shown the S1 row, S2 row and S3 row, which have been denoted R1 row, R2 row, R3 row, and calculation has been shown that first we divide S2 row by 4, then with the help of this row we make S1 row and element under x2 will be 0, and for S3 same, element under x2 will be 0, and in Zj minus Cj element is 0 under x2. You need not to do the calculation separately as I have shown in the next slide. Only thing, you can write the same calculation on this iteration number 1 table itself. So just for understanding that has been, we will write the pivot row. Here pivot row is R2. So R2 value is R2 odd upon 4. So after dividing by 4 we get this, and here pivot element has become 1 now. Then R1 new will be R1 old plus R2 new. So this is R1 old, R2 new, this we have calculated just now, this value, and R1 new with the help of this formula. Then R3 old we know, R2 new we have calculated, and R3 new is R3 old minus 3 R2 new. So we will get this in next iteration. These are the now values. We write down next iteration which one is most positive. This one, this is pivot element, this is pivot column, and now we will divide xb by x1. So we get 10 upon 5 upon 2, which is 4. S1 is leaving, x1 is entering, and this is pivot element. We divide S1 by 5 by 2 and make it 1, and with the help of new row, the values, new values, will make these elements as 0, these 3 elements, and Zj will change accordingly, because in Zj minus Cj we will add Cj and we will get Zj. So for each row corresponding elements have been calculated. Calculation on rows will be first pivot row. Pivot row is R1 row and we have to divide it by 5 by 2. It means we have to multiply by 2 by 5 and we get this row. So this element has become 1. Now R2 row is old is this one. R1 new we have calculated just now here, and 1 by 2 into R1 new is this much. R2 new will be R2 old plus 1 by 2 R1 new, and we get this. Then R3 old, R1 new, then 5 upon 2. We are multiplying it, and then we get R3 new, R3 old plus 5 by 2 into R1 new, and we get this. Once we get all the calculation values we have done on R1, R2, R3, first with pivot row, then rest of the 2 rows, and on Zj minus Cj row can be done on the iteration table and get the next iteration table, which is here, and in this we see that all are negative in Zj minus Cj. There is no positive value, either 0 or negative, so it means we got the optimal solution, and we will stop here. And what is that solution? It is 11 with minus sign, so minimum is minus 11. If we have done with maximum, then we would have been seeing the most negative in Zj minus Cj. and rest procedure was same, and once we get value of z, that would have been plus 11. For minimum we have to put minus sign on that, then it becomes minus 11.